All right, we should be rolling. There we go. All right, we're live. I'm just gonna share. That we're live real quick. Okay. And we're live. I've never done one of these live streams before, but it seems like we got a couple people in here now. So I'm just making sure everything's still working and that I'm able to see the chat. If someone wants to try to test out the chat option, that would be helpful. And then we're just going to get started. Oh, there we go. We got 9 people in here now. Awesome. Okay. So, sorry about that. So I'll just be checking the chat every once in a while, making sure that everything's good. But also, I'll be using the chat to do some Q&A after we get done some labs. I'm not sure exactly what labs we're going to go over. I'm thinking... I haven't done... Oh, perfect. Alright, I got the chat. There we go. Okay, we got 15 people in here now. Perfect. Awesome. Alright, so... I don't know what exactly anyone wants to start with in general, but I could just go over some business logic ones to begin with, and then we can move on to some other labs if people have certain topics to go over. Now, some of these things like XXE injection or OAuth, I haven't messed around with too much, so we might have to go through those together. But we can start out with some business logic vulnerabilities, and everything's going to be done on Burp Community Edition, so you should be able to follow along, and if not, we can see what features we are missing, and I can try hopefully one day to make an extension for that. I'm just going to try to find the appearance real quick. Here we go, dark mode. Perfect. And then I'll bring up the font size just a little bit so everyone can see the screen. Okay, we got 21 people in here now. Perfect. So I'm just going to get started here with some business logic vulnerabilities, and we're going to go through them pretty slowly so that we can understand them, and then we can use this later as some training. So let me just access the lab here, and then I'll copy the URL into my Burp proxy tab, and that will or our Burp browser, so then we'll be able to see that traffic in our proxy tab as well as HTTP history. So let's just take this URL, populate it into this browser, and then we can minimize our actual Chrome browser for a little bit. Okay, so yeah, sorry if my voice stops talking for a couple seconds. That's just me checking the stream, making sure I'm not missing any chats or notifications. Alright, so let's get into it. So this is excessive trust and client-side controls. So basically what that means is that the server is excessively trusting what the client provides to the server. So that means we could be able to manipulate things such as the price or the quantity of items. So let's go to the account, and we first have to log in with our credentials. So it's just going to be Wiener Peter. So Wiener. Oops. Let's just copy this so we don't mess it up. And then Peter. Perfect. Okay, so as you can see, our store credit is $100, and the lab is saying you can exploit a logic flaw in its purchasing workflow to buy items for an unintended price. So this kind of gives us a hint at what we're looking to mess around with the client side, and that's the price. So that'll be our first target when we're looking at the HTTP history of that. So let's go get one of these leather jackets and put them in our cart. So as you can see, it's now in our cart, and we have a few options here. So we can either add a coupon, up the quantity, or remove it. And then as you can see, we'll do this, and now we can see that we're changing the cart with these post requests. So let's see what happens when we try to place an order with just 100 store credit. As you can see, not enough store credit for this purchase. So here this is the error that we get, but this is our post checkout. So as you can see, it's just sending a post request with a CSRF token. So let's see if we can intercept this traffic and see if we can manipulate this price. So we only thing that we see here is a CSRF token. Sorry, I'm trying to read and do the thing at the same time. Okay, so that won't work. This coupon function is interesting because this could allow us to apply like multiple coupons to the same price, but I'm pretty sure that is not what is intended for this lab. That could be in something like race conditions where we're able to apply more than one coupon to the target. But this is stating directly that it's within the client side controls. So let's see what that's about. Okay, so let's go back to intercepting when we first put this in the cart, because when we try to buy it, there is nothing editable except the token. So let's remove that from our cart and see if this can bring us along anywhere. So let's intercept again. We could just view details and forward to that real quick. And then when we go to hit add to cart, let's see what type of request we get. Okay, so here we go. So this is where we'll be messing around with the actual price. So the price actually gets sent to the server when we add it to cart, so not when we buy it, which is an interesting way to handle prices. So the first thing we're going to do is just try, we have $100, so we could try to manipulate it for only $22. So all we're doing here is just looking at the post requests to add this to our cart, and then we are looking at the request body, which are these parameters right here, and we're manipulating this price parameter to a cheaper cost. And the reason why this could be the point of interaction is because the server has too much trust within the client's request. So in a secure environment, this would look like this wouldn't matter because the server would be validating that this price is coherent with the actual price that's listed and not just what the client is sending. So let's send this request through, and then we can get rid of the intercept there, and then see since we edited that price and the server is not validating that, then we get our 22 cents. So we can place the order, and boom, we just solved the lab for that one. Now we can go back and we can read the solution real quick just to go over everything again. So the order is rejected because we didn't have enough credit. That's correct. And then from there we look to see that when we add it to the cart, that is when the price parameter gets sent to the cart endpoint with that post request. And then we were able to change that and send the request again, and boom. So that's how we're able to exploit excessive trust. Now, most modern applications won't allow you to do things that easily, especially with checkout logic, because they understand that that is probably one of the main attack surfaces of that. Okay, so let's load up this new one. This one is high level logic vulnerability. So let's just clear out our burp real quick. Okay, and then we'll access this one as well. Good to see we got 43 people in here. That's really awesome. I'm not expecting this many people to be here at all. This is great. Alright, so once again, we are in a shop. And I'm just going to log in real quick. Wiener. Peter. Okay, no thank you. And let's see what this one has. Oops, I logged in on the wrong spot. Let's log in on Burp real quick. Wiener. And Peter. Okay. So this lab doesn't adequately validate user input. You can exploit a logic flow and purchase to buy items for an unintended price. To solve the lab, buy a lightweight leather jacket. Okay. So we're looking at the same thing again. This time, instead of going backwards, we're just going to proxy every request just to see what it looks like, and we can explain it step by step instead of wasting time. So we're first going to view the details of the actual jacket, and the same thing as before, intercept that post request to the cart. And as you can see, the price is not getting sent, the price parameter is not getting sent within this post request to the cart, so we could just forward that. And then let's go to our cart real quick. So as you can see, the price is not manipulated, probably because they understand that, you know, adding it to the cart, they're adding another layer of verification there. But let's see what this high level logic vulnerability means. So first, I'm just going to try to place an order with 100 store credit, and what we'll see is still the same thing. So it's only a CSRF token. So that's an interesting way. So this is still getting us to look at the adding to cart, apparently, because we're not able to manipulate anything within the actual placing thing. So let's go look at that again. So, oops, I hit the lab description by accident. 1 second. Oh god. Okay, I think we have to open it up. Oh gosh. What did I do? Can I hit the... Nope. Nope. This is the wrong one. Okay. Let me see. It's going to get me to log back in. Hopefully it doesn't... Okay, 1 second while I try to not leak anything too important when I log in here. I'm not sure why it's getting me to do this. Let me see if I could just do it from here. Sorry, guys. There we go. Okay. Back to where we were. So now we're just going to look at the adding to cart logic or request again. So here's just the get to the actual thing, and then we're going to add it to cart. So what I'll be looking for here now, since we know that we can't directly manipulate the price, if we can manipulate some other parameter within this request, so we can either manipulate this product ID, but that wouldn't make sense because this product ID is tied to the actual leather jacket. So if we were to change this, it would only pick another item that they have in this shop, and that would only lead to us buying a different product and not exactly this product. Then obviously we have the redirect to the product page and also the quantity. So the quantity is probably where I would test next, just because there's only a couple editable parameters, and if we change the quantity, so if we change this to 0 and the server accepts that without any validation, that would allow us to buy basically 0 of this jacket. But if we're able to use this product ID, then we are technically able to get that, follow that through to the account. So let's see what happens if we just send a 0. Let's go to the cart. So the cart's still empty. What if we go back, view details, and let's add a -1. This time this messes up the server side logic sometimes, because this messes with the math or the way that they're normalizing the numbers in the back end. So if this just gets sent, well, we could see how the server reacts when this gets sent. So let's send those through, and then as you can see, okay, so that works. So we have -1 quantity, and basically this is just it's flipping the logic that the website is supposed to have, or that the server is supposed to have. So as you can see, now we have the total cost is negative 1,337 because of that integer flip within there. So now we can just place this order, and in a real application, I have seen things like this where you just flip that integer. But if they do have some type of like payment methods, the payment might not go through just because of how the payment processing works. And if it needs to like validate your card and things like that, it might not actually get sent. But you could still report this as a logic vulnerability, because I'm sure there are ways to kind of get those orders through. So let's see what happens after that. Cart total price cannot be less than 0. Alright, so let's see what happens when we send another place order here. Let's intercept the response to this request. Basically what that's going to show us is 303 see other, so nothing there. Okay, so we have the quantity parameter that we can edit. That's a good start. But now we are getting the error of a cart total price cannot be less than 0. So basically what we have to do here is we can try to trick the application into letting us slip this leather jacket through, and we can buy another thing from the store that it costs less than $100, so that our cart price is not less than 0. So let's see if this works. So now we've evened out the integer logic, and let's see what happens when we try to place this order. We can do it without intercept on for now. Okay, so cart total cannot be less than 0. So we have to even this out. So let's see what happens if we put this to to 0. Okay, so it goes to empty. So we still have to keep that one -1 in there. Let's see what happens if we add. So if we go here, -1, send that through, okay? So that turns to -1, and now we can see if we can try to slip this past using those error messages again. So let's look at the first error message. My burp's about to explode. Let me see if I can open this up a little bit more. Alright, so as you can see, we have the name, price, quantity. There's the price. I wanted to see the error message that we were getting before. I'm not sure if we're able to find that here. Here we go. Negative total. So that's the error that we're getting. Let's just see if we can see anything through this. So we only see the inputs here, quantity, value 1, and then that burp protection still didn't allow us to slip that leather jacket through. So let's see if we can add some other things to the cart. So basically, we just have to get this to. Let's get that error message again, so we can post this. Okay. And so basically, if we look at that error message again, we have to get it to maybe equal 0, and that will be how we're able to solve this. So let's just look through the error message. Cart total price. Okay, so what we have to do here is look for something more expensive so that we can even out the cart total quicker. So let's just get this giant enter key, and then we can put in 33 and just see what that evens out to in our cart. Okay, so there we can lower this by a little bit just to get it to below. Okay, so now we should be good. So our total here is only $28. We have 100 in store credit, so we should be able to buy this, and this quantity is at a -0. So let's see what happens when we send this request. Perfect. Okay, so as you can see, we only used a little bit of our store credit, and then we were also able to purchase that leather jacket and with a quantity of -1. So this price did not get sent to the server, or it got sent to the server, but it got invalidated because of this negative integer. So it's messing with the higher level logic within how the server processes those requests. Okay, let's go look at another one. Just checking my stream. Awesome, we got 61 people in here. Sick. Let's just refresh this, see if we got this one solved now. I'm not sure why it's saying we didn't solve it. We bought it. Let me see if I'm not sure exactly why this isn't saying we bought it, or it's not solved. I mean, we bought it. Let's see what the solution says. Place the order to solve the lab. Request a suitable negative content for more units than the card currently has. Confirm that you have. Okay, so it seems like we have to actually reverse the logic. So instead of doing it where we make the leather jacket negative, we're going to do another item as negative and then basically credit our account with the actual price of the other one. So I'll show you what that looks like. So there was technically two ways that we could have done that. If we were buying a negative, sorry, I'm trying to get my browser back. Where does my browser go? Oh, it's over here. The new Burp update has me a little confused. Okay, so let's sign in again real quick, and then we can try to run through this pretty quickly. So basically what we have to do, instead of changing the quantity of the leather jacket, we're doing it to another item so that we can even out those numbers. So let's just grab the COM tool real quick. We intercept this, and then we could change this to -1. As a matter of fact, we'll probably do, let's just do -15 for now. Okay. So as you can see, now we have the negative account balance, which will not go through the server. So if we go back here, add this leather jacket to our cart, now we should be able to even out that price. So see, it's still -$12. So if we just add one, now our total is only $77. But since we use some store credit, we can't do it with this. So we have to find a less expensive. Uh-oh. The logic messes up when. Okay, 1 second. Let's see if we can. See if we can remove all these from our cart and then do it with a different product that's a little cheaper so that we can edit the price a little better. So let's just do burp protection, and I'll do this with our windows here so that we can see a little better. Alright, let's add this to cart, intercept this request, and then we'll just start with -11, and we'll see where that gets us. Okay, so we can add basically these negative, and the reason why I'm going down is because the server is processing that backwards. So a plus would go make this smaller, and the negative or subtracting would actually make it bigger because the server is interpreting that negative integer backwards. So if we keep going down, we can lower the price all the way down to $70 something, and then we'll be able to purchase that jacket. So basically we had the vulnerability, but we had the logic flipped, which is really interesting because not a lot of testing goes into that type of logic in real applications, so it's really something to look out for because people might not look for this exact type of logic vulnerability. Alright, so let's try to place the order now. There we go, and then boom, we solved the lab. So real quick again, we set this price or this jacket to a normal price, normal quantity, and then we used the negative integer logic on a different product so that we could even out the balance within our account, and then we were able to purchase both of those items for only $17. Okay, let's clear out this now since we finally completed that one. And then let's look at the next one. Gotta take a Red Bull break real quick. Okay. Let's start this one up. This lab's flawed logic allows arbitrary users to access administrative functionality that should only be available to company employees. To solve this lab, access the admin panel and delete the user Carlos. Carlos is always getting deleted. Let's see what this one looks like. Okay. So, first thing that we can see in the lab that I would like to point out is that now we're dealing with administrative functionality, and then like an admin panel. So the first thing I would like to try to do is like find the admin panel, because then we can see if we need to, if we get another login prompt, or if we need to have some certain parameters within our request to be able to send something as an administrator. So let's see what that actually looks like on the website. So first we can just log in with Wiener Peter and see what we can see. I'm not sure if we're actually supposed to log in here, so let me just double check. Okay, so we're not actually logging in here. So we do have the register function and an email client. Okay. Alright, if you work for no one to copy here. So we could just say, we could just do admin, and we'll basically, when we register here, we're going to see if the admin username is taken. And one quick check we can do beforehand is also just go to /admin, see if there's an admin portal. Okay, so admin interface only available if logged in as do not want to cry user. Alright, that's a good hint right here. So this user is actually able to use the interface. So if this wasn't here, then we would have to enumerate usernames to be able to find the admin login, basically. So let's just try that username at first, and then we could just do at don'twannacry.com, and I'm just going to use this email as the password as well. Okay, this gets sent to the email for registration. So we actually have to send something to here. Let's see what that looks like. So basically what I'm doing here is just looking at the functionality of the actual site and see what the register link looks like as well. Okay, register, temp registration token. Okay, so here, let me click on this, but we're gonna intercept this, because basically what my thought process here is, this registration token could be used just not for the email that we're trying to register with, but any email. So next what I'm gonna do is, let's just see what happens when I click on this and we go through the normal flow. So the account was registered successfully. Let's see what that looks like here. If we go to my account, nothing there. Okay, and what we see now, so if we try to go back to that same token, that token gets invalidated because it was already used to register. So let me just take another quick Red Bull break, and then we can try to exploit this token functionality and see if we can falsely register the admin email or username with one of these tokens. Okay, so let's go back to register. If you work for them, don't register. Okay, so let's just put another name here, and then don't want to cry. Actually, if we can't send that again because it's going to send it to the same email. So actually we can't get another token. Let's see if we can log in with this. Okay. Oh, okay. So now we have our account as Don't Wanna Cry. So can we use this username to access the admin panel? No. So okay. So this is actually saying not as the Don't Wanna Cry user, but it's saying as a Don't Wanna Cry. So it's only verifying the email domain, and that's basically how you get access to the admin functionality. So I guess the next step here would be changing the email to something like this, the Don't Wanna Cry. And what we can try here is if we don't have to put in a code or something, if we update this email, then basically we're able to have this don'twannacry.com as our email, and basically there's no other validation that we actually own this account at this domain, and that should allow us to access the admin panel. So let's see what happens when we update our email. Okay, perfect. Yep, see? So we're actually able to literally just bypass the security controls just by changing our email domain, and there's no email verification for that domain. So now we're able to go in here, and as you can see, there's our registered user, and we can just go ahead and delete Carlos, and that's the lab. Okay, so let's clear all these out first, and then let's look at that attack path and quickly go over that again, just in case if I didn't really specifically say what was going on. So let's just make sure that we got it solved. Perfect. And then let's look at our solution. So go through, and this is basically just saying that Burp can run content discovery, but we kind of shortcutted that because we know that normally admin panels are something like /admin, /administrator, /admin login, something like that. But I'm pretty familiar with the Burp ones just being /admin, so that's what I went to right away. And as you can see, it said we got that error message saying that we only don't want to cry users can access the admin page. Then we were able to register with any email ID, still not being able to access the admin page. But then once we confirmed and logged in and everything, we were able to change that email address to any Don't Wanna Cry domain, and then we were able to access the panel. So definitely more of a vulnerability that could be out there. Email verification is something that's pretty interesting to look at if you can register different domains, or it's just a great way to start to look for things like account takeovers and whatnot. Okay, so there seems to be a good amount of business logic vulnerabilities. I kind of want to see do you guys want me to look at any other types of vulnerabilities? I know we have about like 78 people in here. If anyone wants to type into the chat, and we can see. Let me just see if there's any more messages. Nothing that I'm seeing here. But if anyone wants me to go over some specific ones, we could try something like race conditions, or we could do SSRF. If anyone has something that they would like to see, let me know in the chat, and we can look at them real quick. If not, I'll probably do either a couple of these race conditions and then also a couple SSRFs. I think this stream ends around 10:30 because I only get 1 hour on X so far. So let me just see if anyone says anything. I'm not getting anything in the chat, so we could just do a couple of these race conditions and then we can also do one of the SSRFs. And then that should be some basic lab solved. I could try to keep doing these basically just going through all of the labs, and then I'll turn these into YouTube videos so everyone can watch them at a later time as well. And yeah, basically just going through them through the mindset that I am kind of helps just get you thinking in the way that maybe an attacker would think, and giving you more context instead of just reading through the solution, because we're able to have this trial and error if maybe the first attack path that I select doesn't work. Okay, perfect. So this is what I was talking about earlier with the cart and the coupons. It's pretty obvious here. I could go over what a limit overrun is in a second, but basically, let me just log in real quick and then we can do that. Alright. So let's log in to the shop here. Okay. So as you can see, we have $50 in store credit. And then obviously the biggest thing here that we've seen that weren't in the other labs was this coupon code. And then now we're dealing with race conditions, which is exactly what I was talking about, where we can try to use a race condition to apply more than one checkout code. And the reason why this is working is due to the vulnerability such as a limit overrun. So in simplest terms, it's really in the name, but we're using a race condition, so sending multiple requests at the same time so that the server can't identify all of them, and we're trying to exceed a set limit that the server has, and basically doing that with those race conditions. So I could show you what that looks like here. Let's see if this is actually how you're supposed to exploit it. So we can add this leather jacket to our cart, and as you can see, the price is still the same. And if we add this promo code, hopefully we can get rid of it, so I could just show you what it looks like without doing it, but also with. Okay, perfect. So we're able to apply that one code, and that gives us a $267 reduction. Now let's just see what happens if we tried to apply this code again strictly through this coupon box. Okay, so as you can see, the error here shows that the coupon was already applied. So this is basically the server invalidating that coupon because it already has sent one through. What a race condition does is it sends them at the same time, so that the server has a harder time differentiating between those requests. So let's remove this from the cart, and then before we hit apply to that coupon, we're going to intercept the request and hit send. And then as you can see, I'm just going to send this to repeater so we can look at it real quick. Let's put it this way. So as you can see, the coupon is here, and then this is getting sent to that cart. So what I like to do to test these things sometimes is literally just hit Control R or Command R depending on your device, and then I'm just going to make 15 of those tabs. So right now we literally just have 15 of the same requests in repeater, and we didn't send any of these yet, so the server cannot see this. Next, we're just going to create a tab group here, and basically what this is going to allow us to do is bunch all of these requests together, and then that will allow us to send them in parallel, which basically means just at the same time. Okay, so now they're all grouped, so that means if we hit this drop down caret right here next to the send button, there's a couple options. So we can either send this in sequence, so basically it would go one after another, probably either really fast. The single connection is faster than separate connections because it's all inside one request. But then this is what we want, which is the single packet attack, which is sending all of those requests within one packet, which is pretty hard for the server to differentiate that, especially if there's no protections in place beforehand. So let's just see what happens when we send all 15 of these coupons at the same time. So the coupon was applied for the first one, and then let's see if it was applied for the second one. Yes, it is. And this is where you can see we're already bypassing that logic of where the web app said that we can't apply any more coupons. So if we go all the way down our repeater tab here to the 15th one, each one has that coupon applied, so we don't have to keep the intercept on anymore. And then as you can see, we still get that error because the server, actually it's probably from before, but if we refresh this page now, you can see that the coupon was applied definitely at least 15 times, and then that is our total reduction because it's been applied so many times. So now we could place that order, and boom, solve the lab. So that's using a race condition to overrun limits, and this can be applied in many different scenarios, not just in checkouts, but in purchasing things, editing things like emails. Just you can use race conditions in so many different ways for timing attacks or these limit overrun attacks, which are pretty fun, and you might not think that they're common, but not a lot of people look for this really too deeply. So if you can find an application that hasn't been used or hasn't been tested on, you could almost certainly find some type of broken logic within that. Now it might not be as critical as purchasing something like that, but you can definitely use that to your advantage within bug bounty or different types of tests. So let's go. Okay, perfect. So the first one was solved. And then real quick, if anyone has a suggestion, if they still want to stick to race conditions or want to move to SSRF, I can do one more of these race conditions and maybe get in one SSRF, but I'm kind of running out of time here. I only have around 13-ish minutes, so we could try to go through these pretty quickly. I almost see that we have almost 100 viewers, so that's pretty awesome. Okay. So let's read this one real quick while we start it up. This lab's login mechanism uses rate limiting to defend against brute force attacks. However, this can be bypassed due to a race condition. To solve this, lab work out how the race condition to bypass the rate limit, successfully brute force the password. You should be able to use the following. Okay, so first let's just, oh gosh, we have a time limit here. Okay, let's go quickly. We have two different types of time limits now. Okay, workout. So we have to sign in real quick. And then we just have to remember that we have to copy this password list in a second. So successfully brute passed. Okay. Brute force attacks. So actually, I'm going to try to log out and try to log in with this Carlos. And then what we can do is, because we probably can't test much with brute forcing if we're already logged in under an account. So I'm just going to type in a random password here and intercept that, and then we can see if how we get brute forced or how we get rate limited. So let's just send this to repeater, and then we can get rid of this group. Alright, so let's just send that. And some things I'm looking for here. So we have nothing in the headers. A common thing that rate limiting will do is show the amount of requests that were sent or if they're getting blocked or something. So we do have this little, that's just our timer for the actual lab. And then we see the invalid username. So let's just keep sending this request a couple times and see if we get rate limited. Okay, so here we go. You have made too many incorrect login attempts. Please try again in 51 seconds. So we might have to wait that 51 seconds so that we can do this again without getting blocked, just because of how many requests we sent. Hopefully I can do this in time before the stream shuts off. So let me just get this all set up. So I'm going to send this to Intruder. And let's get our simple list. And what I'm going to do is copy this word list and paste this right into Burp Suite. So there's our 30. And this might not be the easiest way, to be honest. You might have to use Turbo Intruder. I don't know if we're going to have enough time, but we could try. Turbo Intruder. Let's install this real quick. Okay. We're going to see if I can remember how to use Turbo Intruder really quick. Okay, so this is just doing for word and word. You know, we can try to do this in Intruder and see if it works. Basically, we're gonna have to add these things right here. Okay, so it's just gonna test this password parameter, and it should be past a minute now. I don't want to send it again because we might get stopped. So what I'm gonna do is go to payload pro. Nothing here. I need to find where I can set how many concurrent. I think it got changed within the recent update. Oh, here it is. Yeah, see, I can't, I have to get used to the new UI. But basically, we go to our resource pool, and as you can see, it has 10 concurrent requests, but in our payloads we have 30 requests. So what we're going to try to do is we're going to make 30 concurrent requests so it goes at the same time, and then let's see if we could just use this as just using this resource pool. So it might not work just because of how slow it is. And invalid. Session does not contain the CR. So I wonder if the CSRF token got invalidated that quickly. Thing to look for is these response times, or these response lengths. So as you can see, the invalid username comes back as a 3602, and then we get a redirect with football. So that means that this could be the password, because all of these other ones hit 400. So that could also mean that this is probably why we're getting that CSRF token thing, because we already able to log in, and that invalidated our last session. So main things you want to look for when you're using Intruder or Turbo Intruder or like FF, things like that, is not only the status code like that showed us here, but also the length, because sometimes you might get the same code but the actual response length will be different, and that's like the only differentiator. So let's try this password football here. Let's see if I can log in real quick. Carlos football, and then I'm not sure exactly what happened here. Let's see. Login and access to admin pad. That should be it. Carlos football. Perfect. There we go. We're able to get in and do that just in time with 5 minutes left on our live stream. So I think I'm just going to call it here with the burp, or with the labs, I mean, just because we don't have enough time really to start another one. I will try to be doing these more often in the future. I think this is a good way, not only just to, warm myself up on these different vulnerabilities, especially because I haven't dealt with all of them yet. Like XXE injection, I barely have any experience with that. Like, I understand the broader concepts, but I've never actually done them within a lab practice and kind of done that like trial and error, which really that gets you so that you can learn the behavior of these applications and kind of correlate that to actual targets. So next time we can get into things like SSRF or continue things like business logic vulnerabilities. Yeah, I think business logic vulnerabilities are definitely one of the ones that are going to become more of an issue now that software as a service applications are really expanding, and things like AI coded websites and whatnot, they might not think about all of these checks when they are developing the applications. So with the widespread use of that, I feel like there's going to be a lot more logic flaws, because the chatbots might be able to generate code that does like input validation or path normalization, stuff like that. But when you get into logic vulnerabilities, that's more critical thinking than really how the server is validating things. Now you still have to use that validation, but you have to exploit how the actual system is working and not just a single parameter or something like that. So if you guys have any questions real quick, if you want to throw them in for like the last 3 minutes here, I'd be happy to answer. Thank you for so many people showing up. There's about almost 100 people in here, so it's really cool to see. I'll try to do more of these in the future, so then maybe we can have a little bit more of like an active chat or just more interaction. Like I said before, I'll post this if I can grab the video off of X. I'll post this on YouTube as well, so that people can watch it both here and on there, and then you'll be able to go back and forth and look at the different parts of the labs that we solved and kind of look through my explanations. But as you can see, I have not worked that much within Portswigger labs. I've definitely read a bunch of the different vulnerability labs or the vulnerability types and looked at that kind of course material, but I've been saving the labs, one, just so that I can refresh my memory from time to time with different types of vulnerabilities, but also to do things like this where I'm more interacting with the community and kind of walking through my entire thought process, so that we get more contextualized solutions to these labs. Yeah, access control vulnerabilities are another big one that is kind of like an underlying layer of applications where you're not really looking at like injecting things. You're kind of looking at the reverse logic of how the server is interpreting things and exploiting that. Yeah, there's definitely a lot to go through here, and it's really exciting because there's a lot of fun things to look for when you're doing these types of bug bounty expeditions or just learning web vulnerabilities in general. So I'm not really sure how this is going to cut off.